Welcome back. Let's look at solving radical equations today. In this lesson, we're going to look at solving radical equations in radical form, and we're also going to look at them in rational exponent form. So let's go ahead and take a look at a couple of examples. In example 1, let's take the square root of 4x minus 5 and set it equal to 2. Now what we've got to do is think about, since we have an equation, about our inverse functions. And if we remember, if we have the square root or a radical, what undoes the square root? What undoes the square root is squaring. So what we're going to do is we're going to take the square of both sides. And if I square a radical, we're going to end up with that radicand, or 4x minus 5. If we take 2 and square it, we're going to end up with 4. And now we have a linear equation that we can go ahead and solve. I can go ahead and add 5 to both sides. So 4x equals 9. Dividing by 4, x will equal 9 fourths. Now a good thing to do at this point in time is to go ahead and check ourselves to make sure that this answer works for us. So let's take our 9 fourths and substitute it in for our x in our original equation. So I have the square root of 4 times 9 fourths minus 5, and I want to know, does that equal 2? Well, 4 times 9 fourths gives us 9, so we have 9 minus 5 under our radical equal to 2. 9 minus 5 is 4, so we have the square root of 4 equal to 2, and the square root of 4, well, it certainly does equal 2. So we get a true statement. So we know then that x is going to equal 9 fourths. Not as important today, but later on we're going to see where we get some extraneous solutions. Let's go ahead and look at example 2. In example 2, we're going to get just a hair more complicated. So we're going to have negative 10 plus the square root of 2x plus 1, and we're going to set that equal to negative 5. Notice here, our radical has a negative 10 tacked on to it. And remember, radicals act similar to what variables did. So if I'm solving an equation with a radical in it, I need to solve for the radical first. So you might want to make a notation over here, solve for the radical first. So if I do that, I want to get rid of this negative 10 by simply adding 10 to both sides. So I end up with the square root of 2x plus 1 equal to 5. Now I can go ahead and undo the radical by squaring both sides. So I end up with 2x plus 1 equal to 25. And now I have a linear equation. So I can go ahead and subtract my 1. So I get 2x equal to 24 and divide by 2. So x equals 12. Now remember, we want to go ahead and check the solution. So if I take my 12 and plug it in, 2 times 12 is 24, plus 1 gives me 25. The square root of 25 is 5. So negative 10 plus 5 certainly gives me negative 5. Now if you want to write that out, you can, but you don't have to. Now let's go ahead and look at another example. In example 3, we're going to have it very similar to what we saw in example 2. We're going to see the square root of 4 minus 2x plus a 4 equal to 5. Again, we're going to solve for that radical first since it acts like a variable. So we're going to get rid of this 4. In this case, we're going to subtract 4 from both sides. So I get the square root of 4 minus 2x equal to 1. Undoing the radical, we're going to square both sides. So we have 4 minus 2x equals 1. Solving for x, we're going to subtract 4. So negative 2x equals a negative 3, and divide by negative 2. So x equals a positive 3 halves. Now again, we want to go ahead and make sure that that works So plug it back into our original. Negative 2 times 3 halves gives us negative 3. So 4 minus 3 is 1. The square root of 1 is 1. And 1 plus 4 gives us 5. So again, that one works. And that'll take care of our radical form. Now, we all know that we can change radicals into what? That's right, rational exponents. So we're going to go ahead and, in these examples, go ahead and show a problem that has a rational exponent and how we would go about working that type of problem. So here we're going to take 2 times the quantity of x minus 2 to the 2/3 power, our rational exponent, equal to 50. Before we can go ahead and solve this and get rid of that rational exponent, we first want to get rid of that 2. Now, if you notice, we have 2 times that quantity. So to get rid of that 2, we're going to divide both sides by 2. So we have the quantity of x minus 2 to the 2/3 equal to 25. Now we have to think about what undoes the 2/3 power. If we remember our exponent rules, what we can do to get this to equal 1 would be to simply multiply it by its reciprocal. And that's simply what we're going to do here. We're going to take the 3 halves power and take it to the 2/3. Or take the 2/3 power, and take it to the 3 halves. So we're going to take our 25 and take it to the 3 halves power as well. So notice when I multiply, since I have an exponent to an exponent, these 2 exponents become 1, or to the first power. Now if I look at 25 to the 3 halves, let's come off to the side and talk about that for a second. Remember, I can take this into radical form. My index is my denominator, so I have a 2, and my exponent is 3. And remember, that 3 we can write on the outside of our radical, because it's easier to simplify the radical first and then take it to a power. So the square root of 25, we get 5 to the 3rd power. But remember, if I take the square root of 25, I could have positive 5. I could also have a negative 5. So we have to be very careful when our denominator is even, and you might want to write this out, when denominator is even, we can have 2 answers. Remember, if it's odd, we're only going to get 1. And that should be hopefully from when we were simplifying radicals and changing them to exponents before. So now we're looking at plus or minus 5 to the 3rd power. Well, if positive 5 to the 3rd is 125, and negative 5 to the 3rd power is negative 125. So I have plus or minus 125 as my answer. Now we want to go ahead and solve for x. In this case, we can go ahead and add 2 to both sides to get x by itself. So I have x equals 2 plus or minus 125. Simplifying this, x plus 125 is 127, and 2 minus 125 is negative 123. And there's our 2 answers with this. And what we can do is go ahead and check again. If I take 127 and plug it in for x, 127 minus 2 is 125. 125 to the 2/3 power is going to give me 25. 2 times 25 is 50, so that one works. If I look at negative 123, negative 123 minus 2 is negative 125. Negative 125, the 3rd root of that is negative 5. But negative 5 squared gives me a positive 25. And 2 times a positive 25 gives me 50 as well. So notice we have now 2 answers for that x value. Let's go ahead and look at one more example like that, just to show you how that even exponent works. So in example 5, let's take 3 times the quantity of x plus 1 to the 4 thirds. Let's say we add 1, and that's going to equal 49 for us. So now as I look at this, we've multiplied that quantity by 3 and we've added 1. Remember, we have to get that quantity to that exponent by itself before we can solve for x. So we're going to subtract 1. So we have 3 times the quantity x plus 1 to the 4 thirds equals 48. We're going to go ahead and divide by 3 to get that quantity by itself. So we have the quantity of x plus 1 to the 4 thirds equals 16. Now that I have my quantity to the exponent by itself, I can go and get rid of that exponent. Remember, to get rid of an exponent, we're going to take the inverse, or the reciprocal, sorry, of 4 thirds, which is 3/4. And I'm going to take that exponent to both sides. Remember, if we do something to one side, we got to do it to the other. So if I take 4 thirds and raise it to the 3/4, these are going to cancel each other out. So I'll be left with x plus 1. Here I have 16 to the 3/4. So remember, we're taking our index as the denominator, which is 4, and this is 2 the third power. The fourth root is 16. We have 2, but remember, since the index is even, we can have the positive or negative value, and we're going to raise that to the third power. 2 to the third power gives us 8, so we have plus or minus 8. So here we have equal to plus or minus 8. Solving for x, we're going to subtract 1. So x equals negative 1 plus or minus 8. Negative 1 plus 8 gives us 7, and negative 1 minus 8 gives us negative 9. Again, we go ahead and test those, plugging in my 7. 7 plus 1 gives me 8. The third root of 8 is 2. 2 to the fourth is 16. 16 times 3 is 48. Plus 1 gives us 49. So 7 works. And we'll also see that negative 9 works. Negative 9 plus 3 gives us negative 8. The third root of negative 8 is negative 2. Negative 2 to the fourth is 16. 16 times 3 is 48. Plus 1 gives us 49. Again, feel free to work that off to the side. And let's go ahead and look at one last example, example 6. Here we're going to take the quantity and we're going to have it to an odd exponent and an odd index. So we're going to start out the same process. We're going to divide by 3 to get that quantity by itself. So we have x plus 1 to the 3/5 equals 8. Now that we have the quantity by itself, we can take the reciprocal of our exponent and take that to the power of each of our sides. So our 3/5 and 5/3 when multiplied together gives us 1. So we have x plus 1 equals the 5/3 root of 8. So off to the side, we can think of this as the third root of 8 to the 5th. The third root of 8 gives us 2. Now remember, when our index is odd, it's going to be whatever sign that number is. So we only get a positive 2 in this case, to the 5th. And 2 to the 5th is 32. Solving for x, we can subtract 1, so x equals 31. Plugging that in, we're going to see that we get a true answer as well. Next lesson, we'll see where we get some extraneous solutions, or solutions that don't work. So, in recap, the things that you need to remember with our rational exponents is that if our index is odd, we get one answer. If it's even, we could have a possibility of 2 answers with a plus or minus. The other thing that you want to remember is that when we're solving a radical equation, we want to make sure that we solve for that radical or the quantity first before we solve for x.